You drop a rock into a dark well, and you hear the sound of it hitting the bottom exactly 2.50 seconds later. The speed of sound in the well is 343 meters per second. How deep is the well? So let's draw the well. There's the rock. So the first thing that'll happen is it'll drop down. We'll say that takes time t1. And that's initial speed is 0, and it's accelerating 9.8 meters per second squared. Then the sound travels back up over some time t2, and the sound is traveling upward at this 343 meters per second. So what we've got here is two time intervals which sum to 2.5 seconds, and that's an equation. t1 plus t2 equals 2.50 seconds. I'm going to call that equation 1. So let's start with the rock in free fall, dropping down. We use this equation of constant acceleration, and we say that initial v is 0, so d is equal to 1/2 of g times t1 squared. I'll call that equation 2. And next, let's consider the sound going upwards at a constant velocity. V sub s is d divided by t2. We'll call that equation 3. So if you look at this, we have 3 equations and 3 unknowns, the t1 and t2 and the d. So my strategy here is that I'm going to eliminate the t1 and t2 that we don't care about and solve for d. So I could use 2 to solve out for t1. I could use equation 3 to solve out for t2, and then I can plug both of those in to equation 1 and solve for d, the thing we want. So let's do it. 2 implies that 2d over g equals t1 squared. That means that t1 is the square root of 2d over g, and there's a plus or minus there, but we know that only the plus solution makes physical sense. We have to deal with that ambiguity at the end. Equation 3 just says t2 is equal to d over v sub s. So now we can plug those in. t1 plus t2 equals 2.5. I'm going to plug the t1 into the left, the t2 into the right there, and it's going to look like plus or minus 2d over g square root plus d over vs equals 2.5. I'm going to solve this for d. So that's not easy, but we can do it. First, let's just get the square root on one side, rearrange there. I'm going to square both sides now, so that the left-hand side is now just 2d over g, and the right-hand side is the square of this little difference there. So 2d over g equals 2.5 squared minus all that plus d squared over vs squared. So I'm going to rearrange that some more, bring everything over to the left. All that stuff equals 0. And now we can make it look like the quadratic equation. Okay, so 1 over vs squared times d squared minus something times d plus something equals 0. That's the quadratic. We're going to set a is equal to 1 over vs squared. So that's 1 over 343 squared. That's 8.499 times 10 to the minus 6. B is this negative 5 over s plus 2 over g. That's negative 5 over 343 plus 2 over 9.8. I get minus 0.21866, and c is just 2.5 squared. That's 6.25. And now I can use that d is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Plugging in all those numbers, I get two solutions, either 25,696 meters or 28.615 meters. So which one? Well, first of all, the first one looks a little too large to me, but we can try to check this by actually calculating t1 from equation 2. That was a plus or minus there, remember. It's either 2.4 seconds or 72 seconds. So, and then equation 3 would just say that it's the speed of sound 1.83 or 74 seconds. So if the first one was negative, then indeed the ones on the right would sum to 2.5, but that's unphysical. And the ones on the left do sum to 2.5. So the correct answer is the 28.6 meters. That's the only physical solution. And we'll round it to 28.6.